Hi everybody, this lesson is about implicit differentiation. Implicit differentiation, if you don't remember or if you hadn't studied it, is basically differentiating expressions that are not functions and for related rates. You know, how different variables change with respect to time. So these are they're not for functions and they're for related rates. So like how distance or how things are changing height with respect to time. So that's why we need implicit differentiation, because there's more than one variable. There's a three-step process, and again, I'll explain it and then I'll do the example questions. First of all, you're going to differentiate both sides with respect to a single variable. When the variable is different from the variable in step 1, multiply by the rate of change expression. And number 3, you're going to solve for the rate of change by grouping all the terms with the rate of change on one side and factoring out the derivative. So I guess in layman's terms, what we're doing is we're going to differentiate by one of the variables and then get them all by itself on one side. So let's look at this first problem. So for example, remember derivative means slope. So say somebody has this graph right here, it's a circle, and this is actually the function for the circle, x squared plus y squared equals 13. So you could plug in numbers, you'll get this circle for x squared plus y squared equals 13. But what if somebody said at 2, 13, 2 comma 3, what's the slope? So what if somebody said, what's the slope here? And, I could make a tangent line, a crooked tangent line, and I could guess that, it has to be a negative slope, but I want to know what that slope is. So I'm going to use something called implicit differentiation. How implicit differentiation works is just like the 3 steps we just talked about. So here's this function, x squared plus y squared equals 13. What I'm going to do is I'm going to take the derivative, like so. Derivative of x squared is 2x. Okay, so far? And then it's going to be the derivative of x, since I'm doing this over one variable, it's basically dx over dx. So I take the derivative, 2x, and I'm doing dx because I'm doing it for the x variable. For y squared, same thing, it's 2, the derivative of y squared is 2y, and because I'm taking the derivative with respect to x, I'm going to put this as dy dx. And again, it's because I'm doing this with respect to x. And you know the derivative of 13 is 0. Now, simplifying this, you know that dx over dx is the same thing as 1, so I'm going to leave that alone. This is now 2x plus 2y. And to make writing a little bit more easier, instead of writing dy dx, I'm going to write y prime. And that still equals 0. Now, what do I need to do? In the last step is I need to get y prime. In some cases you have more than one, but this one only have one y prime. I need to get it by itself and solve for it. So first thing I'm going to do is I'm going to subtract 2x from both sides. So subtract 2x from both sides. And then I'm going to divide both sides by 2y to get y prime by itself. So it looks good. There is something you could simplify. You guys probably can see it. The 2's will cancel, and I get negative x over y. So you might be saying, how is that the derivative? I still don't know what the slope of that line is. Well, if you remember, and especially for implicit differentiation, they tell you what point we want the slope. We want the slope at 2 comma 3. So what I'm going to do is I'll plug in 2 for x, and I'll plug in 3 for y. So I'm going to take these numbers and plug it in, and I will get negative 2 over 3. So the slope, or dy dx, at this point right here is negative 2/3. So that's how you do implicit differentiation, or this is when you have to do it for more than one variable. So that is the simplest version. Let's try a couple that are a little bit more difficult. Same thing, it says find dy dx. But for this particular problem, they want it for this problem. I know it looks very terrible. Alright. On the left side, I have product rule, x sine y. So I'll take the derivative of the first one, which is 1, or here. The derivative of the first one is, the first term is x. So the derivative of the first one is 1, and then dx over dx. And then I'll leave the second one alone, which is sine y. Plus, I'll leave the first term alone, x, and derivative of the second one, which is cosine y. And again, since I'm deriving, This one will be also times a dy dx. Equals, the root of 3y is 3 dy dx. Plus, the root of cosine 2x, if you remember this is a chain rule, is going to be negative 2 sine 2x. Let me just erase that. So the root of cosine is going to be negative sine. Negative 2 sine 2x. And then since I'm deriving again by x, I'm going to do dx over dx. Now in step 2, remember all the dx's cancel, or I mean dx over dx is just 1. So now I'm just going to simplify it, and then everywhere I see dy dx, I'm going to put y prime instead. So this now becomes sine y. This now becomes, just to simplify it, this now becomes x. This dy dx now becomes y prime cosine y. This 3 dy dx now becomes 3y prime. And then I'm going to get a minus 2 sine 2x. So now I've simplified it. Here's the problem. I have y primes on both sides. Okay? And then I have all these extra stuff. So all you have to do is basically move the y primes to one side and the non-y primes to another side. So let's subtract 3y prime from both sides, and let's subtract sine y from both sides. Okay? So I'm subtracting this one, or moving it to the left, and I'm subtracting this one and moving it to the right. The new equation looks like this. Okay, so far? So all I did was subtract sine y, that's why it's now over here with a minus, and I subtracted 3y prime, which is now here, which is now here, and also with a minus. The last step is I need to get y prime by itself. So do you see how these two terms have y prime? Well, in step, at the top, number 3, it says let's factor out the derivative if necessary. And this is going to be necessary because if you notice, I have 2 y primes on the left side. And I need to get y prime by itself, but now I have it in 2 different terms. So I'm going to factor out a y prime, and that leaves me, if I factor it, with an x cosine y minus 3. So all I did was factor the y prime. And the last thing I'm going to do is I'm going to, since it's now factored, since I have y prime by itself now, I'm going to divide both sides by this parentheses. So your answer is going to be y prime equals negative 2 sine 2x minus sine y all over x cosine y minus 3. And all I did was take this and divide it by both sides. So now this I placed onto the bottom, and then that's how I get the answer. And so you're saying like, oh, how come we got a number last time? This question just asked for dy dx. They didn't give me a number, so I just stop right there. So really that's all the time I have. I just want to introduce to you the concept of implicit differentiation. We'll practice more in class tomorrow. So hope you enjoy, and take care.